Okay, this is lesson 4.2, transformations. It's actually day 2 of this lesson, and I want to go over what we learned yesterday. So I would like to right off start you with, here is a function, y equals absolute value of x minus 7. And then I'm going to give you another function. It's going to be g of x, and it's basically telling me directions on how to make a new function out of this by moving it somewhere and stretching it a little bit. And it says to do this, 2f of x, oh, let's make it a little more complicated, f of x minus 3 plus 7. If I take any point from the original function, what I taught you yesterday was how to take that point and move it to a new spot based on these directions. Okay, so let's figure out a point that would be on this. If I put in x is 2, what would have been the result in the original function for y? Absolute value of negative 5, which would be 5. Good. Does that make sense to you? Okay, so that's a point on the original function. Now, where should that point move when I do this to the point? See if you remember how to do what I taught you yesterday and get the new point. I will pair you with somebody so you can compare your answer with them. I'm going to pause for a second while you do that. It was 5,17. But for those following along at home, how did we do that? Miss NA in the back row. Explain how to get the x. You set the 2 equal to the x minus 2. Can you explain why? This is like f of x. Okay, so why are we setting the 2 equal to x minus 3? Because the 2 is the x. And that goes with this f of x. And that goes with this. And therefore, 2 is equal to x minus 3. Okay, what's the other equation you solve to get the other part? It's a little more challenging. Come on, somebody volunteer. Yes? All right, so you took the 5 and you plugged it in right there. Can you explain why you put it right there? This is f of x, excellent. And all of this is the f of x. Awesome. So then it's 2 times 5 plus 7, which is 10 plus 7 is 17. All right, good. So let's move on. We're actually going to go to this first slide. I apologize for my writing there. And this is just asking you to do stretches and shrinks to a graph, as opposed to here's a point and I want you to move it. First, you've got a graph. So let's everybody graph x squared, just the parent function for x squared. Do it with dots. Don't just like go, oh, it's like this. I want dots. Distinct points. Now, once you've got that graphed, this is just a review of last year. You did this for a month last year, so you should be pretty good at these stretches and shrinks and stuff. What we need to talk about is that too. Is it a vertical or a horizontal change? Vertical. Do you remember the little high-vo thing that helps you remember that? How many of you know what I'm talking about? Well, that's a little more than half, okay? So high, horizontal on the inside. There's nothing going on the inside. So there's nothing changing horizontally. Vertical on the outside. That's the high vo. High means horizontal on the inside. Vo is vertical on outside. So this is a vertical change. And that too, is it a stretch or a shrink? Can I trust it or not? Yeah, it seems like you can trust it. This 2 seems like double. And you can trust stuff on the outside. You can't trust stuff on the inside. All right, so would you please just make me new points for all of these spots. Move them to where they're supposed to be. And compare with the kid that I paired you with. I'll pause for a second while you do that. That was a ridiculously long amount of time for how easy that was. So here is your new points, over 2 and up 8, unfortunately off of our smartboard. But I'm going to remove that and that and that and that. And there we have it. Basically, it looks like it's been stretched. You grabbed it and pulled it upwards. Any questions on that kind? All right. So let's move on to the 1/3 x squared. Would you please, I'm going to give you much less time this time. Graph the parent over here and then do this to it, which is definitely more difficult. And you'll have to actually be careful about what points you have. It'll be decimals or fractions, like 1 1/3 is one of your answers, for example. Okay? So would you please make this change and then compare it with your partner? You can do it by the method I just taught you of moving points, or you can do it by just thinking, oh, I need to do a vertical change, and I'll pause for a second while you try that. So let's have somebody come up and do this. Any volunteers? Excellent. Come on up. Now, while she is making this stretch or shrink, I want to talk about where we're headed test-wise. So we now basically have to do more about inverses. Do you remember we had inverses on our last test? Like g to the -1. Remember the inverses? That was a reflection over the line y equals x. We're going to do more with that early next week. And we have some review time, and then we test on Thursday. And that's the last day of the week for you guys. Why? Why do you only have class till Thursday next week? Conferences. Friday is conferences. Okay, so you got a short week this week and a short week next week. Yay. So Thursday of next week is the test. And it looks to me like you have squished this thing. A vertical shrink. And that is exactly right. I would like somebody to explain how this point, which was 2, 4, you could use that point system we just learned to change the point into this point right here. She's right. How would you use that point system to do it? I'm going to call on you. How do you change 2, 4 into this new point right here? Using the point system. Yep. Into the function right there. X stays the same. X is 2. Excellent. And how do you find the y?
You put 4 into everything. 4 into x squared, so x squared equals 4.
All of that becomes a 4. Excellent. Y equals 4/3, or 1 1/3, which is exactly what she graphed right there. Very nice. Thank you. Good explanation. All right, moving on to this one. These two, sorry about pre-writing on there. It's from last hour. These two have been stretched. Would you tell me an equation that would have changed the one into the other? For instance, a person might say this. They'd be wrong, but they might say that. If you look close enough, it's actually on the slide. It is y equals 2f of x. So this one has been stretched vertically. It's been doubled. Look at all the x's. 0 goes with 0 still. 2 goes with 2. 4 goes with 4. 5 goes with 5. The x's didn't change a bit. It was only the y's. All right, moving on to the next. This one. It's really common for people to make a mistake when they do the horizontal, the inside stuff, because they look at it and they go, okay, 1/2 horizontally, so half horizontally. What's wrong with that? It's the opposite of that. You can't trust the stuff on the inside. So this is actually doubled horizontally. Go ahead and draw me what you think this M should look like. And then would you please compare it to the person that I paired you with? I'll pause while you do that. Okay, so this one. Do you see how a person could easily say, okay, so you want me to make it half as wide. And what's wrong with that again? Can't trust the stuff on the inside. All right, so instead you should have made it twice as wide. if I wanted to use that point system I just showed you, 3 comma 4, would need to use this to make a new point for it. The x would become 1/2 x equals 3. Make sure I'm doing that right. Yep. X would be made up of 1/2 x equals 3, and then I'd multiply both sides of x equals 6. So my new point is 6, and then the y of it is 4. That comes over and goes in for this whole thing. F of x becomes 4, so then y is 4. So it'd be 6 comma 4 would be my new point. 6 comma 4 right there. So this point moves over to there. That's how you do it with the new point transfer method. Okay, good enough. Now, look at this next little set right here. And I'd like you to try to tell what they did to it without looking at the answer. Doesn't it look like the graph that they had, the little function, got narrower? And therefore, y equals, it was f of x. You can always start with that. And then how do I make it narrower? I mess with the inside. Seems like it should be a half. Instead, it's a 2. Does that make sense to you? Okay, moving on. This is the first problem of the homework, which I'm going to do with you. And then we are starting your assignment at this point. All right. Let f of x equal x squared. I know that one. It's a parabola. Find and simplify the formula of the function g of x, whose graph is the result of f undergoing the following sequences of transformations. All right. So basically, it's a sequence. It's like a whole bunch of things that are going to happen in a row. It's first going to shift up 2. Let's try to write an equation for that. It was y equals x squared, but then I'm going to do shift up 2. How do I do that? Plus 2 on the outside. Okay, and then it's got to reflect across the x-axis. Wait a minute, now which one is that? Is that horizontal or vertical if it's going over the x? Would you agree that this is the x-axis? Going over that then, what is it, vertical or horizontal? It's a vertical. Vertical reflect. So where do I put the negative, on the inside or the outside? Outside. So now we're up to y equals negative x squared plus 2. Okay, now how about horizontal shift right 1? Y equals negative. I got to make an inside now. And now on the inside you should go minus 1. I agree. And then the last thing, stretch by a factor of 2. I can just squeeze in a 2. Inside or outside? Inside. Oh, all that work and then I messed it up at the very end. What's wrong? I have to put a half in there. It says stretch. This seems like it would stretch it, but you can't trust the stuff in there. Therefore, it's a half. And then the one more thing, this is really critical. It needs parentheses around this. And I bet a lot of you wouldn't have noticed that. I'm going to say that again. It needs to have parentheses on this part. I'm telling you, we just had this test in higher algebra. And I marked that wrong on at least half of the papers. Because people forget these parentheses right here. I'll make them in red. When you do a stretch on the inside, you need parentheses around your move. Otherwise, this half doesn't get distributed properly and it won't work right. You'll end up doing it in the wrong order without those parentheses, and then your graph doesn't go where you think it's going to go. And let me clarify that. Let's say it was like this. Let's say I did it like that. There, I'll write this in red so you can read it actually. They look very similar to the untrained eye. But think about it. With the parentheses, it'll force us to do the 1/2 part first. As opposed to here, we would be doing the move first. And that's what makes them different. So I'm not going to, I could seriously spend 20 minutes trying to explain this thoroughly, but these parentheses are important. Don't forget them. Okay, let's move on. Here's where I want you to start your homework by yourself. I think we have enough practice on these. We've done so many moving points problems that you're going to move the point, apologize for it being kind of fuzzy here, 2 comma negative 3. But we don't need to do all of these, so we're going to skip those. You're going to do 10, 3, and 6. Love the numbering there. And then over on this one, I think all of those are important, and this is kind of the new stuff for today. So we should do all of those, except 48's a little bit extreme. You may skip problem 48. Then, in this little section, I've given you an answer for the top one, just so you know what we're talking about. Notice it says it wants it to be called g. The function g. You're making a new function g. So that's why I called it g of x. I just would hate to have you do this whole section and think y equals y equals y equals the whole way. No, it's not y you're making. You're making a function g. And all it is just start with the square root and then figure out how to do what they ask. Take your x and shift it down 3. Hopefully you know whether that's inside or outside. And shift it right 2. Hopefully if you know that's inside or outside. Okay, and that's it. Easy assignment for today. So I get this right now is not very honors-y. It's not super challenging stuff. I'm hoping you can just enjoy that instead of like, you know, feeling like, oh, I feel bad that I'm not being challenged. Okay? Because you're going to have plenty of challenging stuff in this class. There'll be days where you will say, oh my gosh, this class is so hard. Just enjoy the easy one today. Okay, and that's all I have for the new stuff for today.